In this presentation, I will show you how to use adjacent list to represent a graph in C++. Many word scenarios can be abstracted into graphs, such as cities or the people's relations. In this diagram, the left-hand side are the maps or the people relationship. We can map it into a graph on the right-hand side. In this graph, it consists of 6 nodes and 7 vertices. In the programming language, a graph typically can be represented into adjacent list or an adjacent matrix. Adjacent list is what we will introduce next. Adjacent matrix is a 2D matrix we will introduce in some other presentation. If we are given a graph on the left-hand side, we can use an adjacent list to represent that. Here is an array. In this array, it contains 6 entries, 0 to 5. And also in each entry, it is a list of array. So, for example, the 5 point to 4 represent on the diagram of 5 point to 4. Will the 2 point to 1 to 0, 0 to 1 represent this node 2 have an edge point to the 0 and have an edge point to the 1. So the arrow here is the same as the edges of the diagram. So this is an adjacent list. In the C++, when we implement this adjacent list, typically we have 2 ways. One is using the STL. The other is without using the STL. We will first introduce how to implement without using the STL. So without using the STL, we have to make sure we declare all the nodes. In this one, we have 6 nodes. And however, when we implement that one, we have to declare a structure called nodes. This node includes a value and a pointer to the next. In fact, this node is represent of each node here, not the array. So after we declare that, we declare a head line 36 to point to the at the very beginning of it. And also we declare a help data structure edge with the source and destination to initialize our graph. So in this code, we declare a node, we declare an help class edge, and our main class graph. In this graph, we will get the next adjacent node, trying to add that one. Continued. Also, we allocate some memory using new. We initialize the array. This is heads. Look, with the curly bracket with I to initialize all the adjacent array on the left-hand side, and we try to add edges into this graph. After that, we declare a destructor to release the memory if we do not use this graph. On the line from 81 to 90, we use a for loop to print out this list. In the main function is the driver function trying to declare an array of edges and trying to just construct a graph using this constructor and trying to print out the array. So look at the code. I will go back to the code. This code should be, this data structure is the most important one. In this class, we declare two main functions, constructor and allocate a new node into to build this graph. And in the we have another function to print out this graph and also a main function to test this graph. This is represent this one code is represent a graph using an adjacent list without using the STL. This code is almost a C code. If we remove the class, it will become a C code, also in the C++. Now we will go to the another method trying to use the STL. STL meaning standard template library. We use the STL how to represent the same adjacent list. It's much simpler. So in this one, look at this, look at the line 26. We declare a graph, a list first. This list type is integer as to hold all the numbers or indexes from 0 to 5. And in this list, it has an array. This array trying to represent the right-hand side, the list. They always use the adjacent list here, but in fact, they use an array. So when we print out the graph, we use the for loop to print out the graph. When we add an edges, we are trying to add an edge from into this array. So we use a pushback to do that. So this method, we did not go to the details of the node of the next as we do it in last method. But we have delegate all the relations into an array implement in the vectors in STL. This one, I will show you how to implement the code here. So, for example, without using the STL, this code is here. This code is same code as I present in the PowerPoint. So when I run it, when I build it, no problem. When I add it, because I already added in the main function, so it print out the left-hand side and the right-hand side. Another way, using the STL, the code is similar, it's much shorter. So when I build it and run it, the code is similar like this one. So in this presentation, I have go back to here. So in this presentation, I have using two methods. Using the STL or without using the STL to show you how to use the adjacent list to represent a graph. If you have some other questions, let me know. Thank you.